I'd like to start by welcoming you all on behalf of the traditional owners of the land on which we're meeting today, and to pay my respects to their elders, both past and present. And thank you all for coming at what is a fairly horrible hour of the morning. Some of us were here before it was even light. We're not used to that. Well, to start with, need to let you know or remind you that the government is in caretaker mode, and I'm CEO of the National Measurement Institute, which is a division of the Department of Industry in the federal government. And in caretaker mode, we're not supposed to promote ourselves. So I'm only going to stick my neck out far enough to say that I think NMI is a pretty good organisation. We operate from about 24 sites around the country. We're responsible for Australia's top-level functions for measurement science, in physics, chemistry and biology. And we also serve a regulatory function, being responsible for trade measurement around the country. So we're here to do a couple of things today. Firstly, of course, the occasion is World Metrology Day, the day on which the world recognises the contributions and importance of metrology to our safety, our livelihoods, and our well-being. And secondly, to announce a couple of prizes that NMI awards every year, and these actually have become relatively prestigious over the years, quite a lot of competition for them. And so I'll begin with talking about what we're doing here. World Metrology Day is the anniversary of the signature of the Meter Treaty on 20th of May 1875, and this document is essentially the international treaty by which the signatories agree to use the metric system of units in their day-to-day life and their legal system. And it essentially marked the beginning of formal collaborations in measurement science, because metrology, or the science of measurement, is always has to depend on effective collaboration, because at the end of the day, if the world doesn't agree on what a metre is and what a kilogram is and what a second is and all of the other units, they're going to be useless to us, because measurement is always about having the ability to compare measurements across the globe and maybe one day across the universe. So on World Metrology Day, we award two prizes. The first of the prizes is called the Barry Inglis Medal, and Barry Inglis was the first or the inaugural chief executive of the National Measurement Institute when it was formed from other organisations in 2004. And he retired in 2007, but since then he's gone on to be president of the International Committee of Weights and Measures. And in that role, there is no higher authority in the international system of weights and measures and the metric system of units. He essentially oversees all of it. So we make an award every year in his name, and the recipient this year is the CSIRO Infrared Soil Analysis Group and Zealtech Proprietary Limited. These two organisations have collaborated to build an infrared device, or infrared monitoring device, that is capable of rapidly and effectively detecting the quantity and concentration of hydrocarbons in soil, which of course is a very useful thing in environmental contamination detection. The second, and I congratulate those organisations very much, and later this year we'll have a ceremony, hopefully attended by a Minister of the Day, to actually hand over these prizes. The second prize is the NMI prize, or the National Measurement Institute prize, and it's reserved for young Australians of up to 35 years of age. We like to say that it promotes measurement science and fosters its applications in innovative fields, and encourages younger scientists to actually participate in measurement science. The recipient of the 2016 NMI Prize is Dr. Su-Lin Choi of the RMIT, the Royal Melbourne Institute of Technology. She has demonstrated that the global positioning system and satellite navigation systems can very effectively be used and very simply be used to provide accurate positioning across Australia at the 10 centimetre level using an innovative system of signals broadcast from a Japanese navigation satellite system. And this has significant implications for agriculture and other activities around the world and automated transport, around Australia, because previously such a facility has only been available in areas where there is what we call augmentation signals available for GPS, and these are usually broadcast in Australia terrestrially, but they have found a way to use some signal bandwidth on a Japanese satellite system to actually provide this information and very easily receivable across the country. So again, a very significant contribution to the application of measurement in Australia. So congratulations to Dr. Choi. So our event today is what we call an in-conversation forum. We have had a number of themes for World Metrology around the day. The previous years, the theme has been measurements of energy and light, and covering issues such as the role of measurement in safety. This year's theme is called Measurements in a Dynamic World. And that basically means that we can talk about absolutely anything because everything's changing around the world. But that's very convenient. It means we don't feel constrained. And we're going to have a conversation forum talking about measurement in food, which is, of course, a huge issue and very relevant to our activities here at our Port Melbourne site, which much of our activity here is devoted to food safety and the chemistry and biology behind food safety. We're going to hear from experts in food standards and safety, and they're going to discuss better measurement in food standards with a particular focus on safety and innovation in technology. I'm very happy to say that we have a very well-known national medical reporter here on my left, Ms. Sophie Scott. And Sophie, thank you very much for coming to facilitate this conversation. Sophie's worked in television for many years, including as a newsreader, a correspondent, and a producer for news and current affairs. She's produced and presented documentaries for cable networks in the US and Germany, and she's won numerous awards for her journalistic work in medical fields, and we're really honoured to have her here today. We have a couple of guests as well. We have to Sophie's left, Mr. Peter Schutz. He's the chair of the Food and Agribusiness Growth Centre, and Dr. Samuel Godefroy, if I got that right, it's not that easy to pronounce. He was a full professor at the Department of Food Science at University Laval in Canada. So Peter's the chair of the Food and Agribusiness Growth Centre, and as a founding chair of Food and Innovation Australia Limited, he's over 40 years of experience in the food and agribusiness industry in Australia. His experience in the food industry spans operations, sales, marketing, technical services and compliance, innovation and technology, and Uncle Tom Cobley and all. But it's an enormous list of activities, and sustainability and general management. Sam has worked as a food regulatory official in the Canadian government for more than a decade. He's also served as Vice Chair of the Codex Alimentarius Commission from 2011 to 2014. He's worked on the World Bank's Global Food Safety Partnership and currently serves as a food and regulatory expert on numerous projects led by UNIDO. He also is a fairly robust character, because I have to let you know that he arrived in this country yesterday morning off a flight from Canada. Then he met in Sydney, he met James Roberts, my colleague here at Sydney Airport, and then flew to Canberra, where he took a shower at the airport, and then proceeded to a series of meetings in Canberra yesterday, and then got on an aeroplane last night and flew to Melbourne, and then came out to dinner with my colleagues and myself, and was still on his feet at the end of that period. So it's quite a remarkable event, although there are reports that he fell asleep on the flight from Canberra to Melbourne. Thank you all very much for coming, and we look forward to Sophie facilitating the discussion.
Thanks. Thanks very much. Thank you. Thank you very much, Peter, and thank you for asking me to be here. It's a great honour, and I'm really looking forward to our discussion today. I should start by saying Happy World Metrology Day, or is it Merry World Metrology Day? I never remember. But Happy Metrology Day to all of you. And in our conversation today, we're going to look at issues like how does measurement contribute to food safety? And what I've learnt from the research that I've done for this event is that measurement of food is critical for food safety. And according to the experts that we're going to talk to today, it's thanks to measurements that food control practices can be undertaken, that contaminants or potential contaminants can be identified, controlled and managed. So this morning we're going to talk about how the two industries of food and measurement work together to make our food safer. So welcome to our guests, and I want to start by a broad question to both of you. And how does accurate measurement make our food safer? It's a broad question, but let's kick it off with that. Peter?
Well, I mean, if I go before that, when I started thinking about this conversation, I thought, why the hell am I here? And then I started to think that, measurement really does run our lives, and, both from an unknown sense, but also from a voluntary sense. And I think of all of the devices we wear these days to measure everything, and it's almost totally consuming. But in answer to your specific question about food safety, my assessment is that in Australia or around the world, we're extremely good at measuring once things have gone wrong. We're great reactors, we're great responders to crises, but we're not so good at developing measurements that assure us of safe food into the future with some guarantee. And we've had a lot of incidents around the world. Those of us in the know, when we see an incident occur, instantly think, well, you know why that happened. And it's a failure of the system. So to me, the big issue is about how we build into what we do daily, these measurements, observations, whatever, that prevent things happening. So it's my real push in this area.
And what about you, Sam? So how do you think accurate measurement can result in better food outcomes generally?
Well, first of all, I would like to thank the organizers for giving me the opportunity to be here. It's a true privilege, actually, to contribute to this conversation, and also to commend the National Measurement Institute in Australia to dedicate part of this day and the discussions to food safety, quality, and nutrition. I guess I'm gonna take it from a very practical level and using my experience as a regulator in the past. Clearly, food measurements and measurements in food are so critical in the context of a food safety incident investigation, for example. You wouldn't be able to detect, to identify and characterize the source of a foodborne illness outbreak without accurate, precise measurements that would allow you, in fact, not only to identify the issue, but then to go from that phase to preventing further contamination and actually to properly manage and mitigate the incident from a human health impact standpoint. So again, measurements are a key tool. It's a key vehicle. It's not the endpoint, because generally measurements serve an outcome, serve a purpose. And in this particular case, clearly so critical to have precise and accurate measurements in the context of food safety and quality.
And is it a big issue? I mean, we're talking about measurement in Australia here, but in Canada, what's the experience there with the importance of, do they see the importance of measurement in food safety as well?
I think actually all stakeholders recognize the importance of that. At the same time, we need to be also very careful in that we don't solve everything with measurements. Measurements are but a tool. They're not really the objective. So, one of the general statements that I use in French, so I don't know how it translates, well in English, which is you don't basically get your food safety solution through testing. And in fact, actually, maybe to build on Peter's point, end product testing is not the solution to food safety. In fact, right now, and we're learning from experience, all of us, prevention is the key, and measurements, in fact, again, could be critical in prevention in the sense that testing methodologies in the context of validation of preventive control systems, in the context of food production across the supply chain, they are there really to validate the approach of all the prevention mechanisms that have been taking place, from sourcing the raw material to the various stages of processing the food. Generally, end product testing is really the final element, and it should be, in fact, the last resort for identifying an issue in the context of food production.
And that's something that when you and I spoke, Peter, you talked about the why is predictive testing so important? So you're not waiting until there is a problem that you're identifying.
Well, to pick up on the point, once the product is finished, the horse is gone, it's bolted. So the issue occurs afterwards. You've already, the product's in the marketplace, you've already probably poisoned consumers by the time you become aware of what the problem is. So the predictive area is much more important to me than endpoint testing. But there's a balance between it as well. I mean, one of the roles that I have in Food Innovation Australia, limited in implementing the Food and Agri-Growth Centre, is to eliminate red tape. And the government thinks that red tape is we have 4 key objectives. They think it's the most important. When we go to industry, they say it's the 4th. But nevertheless, in terms of a perspective, red tape is a real issue within industry. So defining regulation and measurements and precise ways of doing things actually is a curb on innovation. So you have this balance. So to me, it's the predictive work and the work that we put in around being able to measure things accurately, but more in a predictive sense rather than at the end of the process.
I work mainly in the health space, and the analogy we use is the ambulance at the top of the cliff or at the bottom of the cliff. Yeah. And that sounds like we need to be getting it at the top of the cliff. Yeah. What's it like in Canada, Sam? Do they have predictive testing, or is it that you're waiting really till it's an outbreak or a problem?
Yeah, I guess actually it's getting so important to move to the preventive mode that in fact it made the way to our food regulatory system right now. I'm sure that a lot of the colleagues and peers in the audience are aware of changes that are happening even in the context of food regulations. We're moving away right now from regulating food on the basis of characteristics at the end point towards what we call preventive control measures, and essentially imposing requirements for control at the various stages of production. What that means in a very simple terms is basically while you're producing the food, you go back and try to identify the potential hazards. You come up with measures to mitigate or essentially manage either the introduction of these hazards or the way they could evolve throughout the food chain. And essentially, you use techniques to validate that whatever approach you've used to prevent that hazard essentially is effective. And that's where essentially measurements could be useful. And in our regulatory system in Canada right now, in fact, there was the adoption of a new law in 2012. It's waiting now its implementation because we've had a number of changes in government in Canada as well, where essentially now we're imposing the implementation of these preventive controls to all processors, whether be it in fact processors that make food domestically, but also imports. In that, we're not, I would say, the only jurisdiction in the world moving in that direction. The United States, particularly through the development and implementation of what is known as the Food Safety Modernization Act, it's probably one of the pieces of legislation that made a paradigm shift in the way foods are being regulated, again, introducing this notion of prevention and early identification of issues and management, as opposed to relying heavily on the final, the inspection of the end product.
Yeah. And in Australia, do we still have a way to go until we get to that point?
Well, no, I think we're pretty close to it, but it's a double-edged sword, because one of the areas of red tape that's emerged as a result of this requirement to do quality audits, etc., is an absolute explosion of a requirement by companies to audit against food safety standards. When we've talked about red tape within the industry, the one that's emerged is quality standards, is quality auditing, as being a burden to industry. We have one company that each year, or the last year, had over 150 quality audits. And they estimate that each quality audit costs them about $10,000. There's $1.5 million of cost to the business to do quality audits, thereby Coles, Woolworths, McDonald's, all the fast food restaurants, all the food service distributors. And if you look at the quality audit system, 90 to 95% of the questions and the surveys that every one of them does on the one person are identical. Yeah. And some of them have nuances. So this is where, bureaucracy and a focus in the wrong area without if I could use the term, the right metrology being used, actually creates a problem out of kilter with what it's trying to do. So that's an area we're working with the Australian Food and Grocery Council to try and get a common approach to it. So
you can streamline those audits so that they're still getting useful information, but you're not doubling up and you're not...
Well, you have a standard audit that everyone must comply with. Everyone must meet it. And if you're McDonald's or you're Coles or even a company who audits a supplier does the same thing. So vendor audit programs. If you look at a bill of material for a company, they might have 1,000, 10,000 raw materials. And a big company who are conscious of quality will actually go out and audit each supplier. So if you start to think of the explosion of the number of audits that occur, and if you look at them, there's probably 90 to 95% of it's consistent standard. And so if you talk about a government initiative, we're actually looking at, in this proposal, to say to government, you need to legislate to say, here is a standard, and okay, you do your 5% outside of it, but let's take this cost, it's an unnecessary and burdensome cost to industry. Whereas I'm picking on only one area.
But that's interesting. And one thing I was going to ask you both about was the issue of, and this comes into it with the audits, is food fraud. So how important is measurement to prevent food fraud with things like fish like barramundi? Instead of getting barramundi, you get a lower quality fish, or there's been instances overseas when horse meat, for example, was being put into processed foods. How important is measurement in preventing food fraud?
Yeah. Well, first, if I may pick up on actually the point that Peter made related to the inflation of audits and so on, and this is clearly a problem that is faced by industry, but also faced by regulators. And in fact, we're seeing right now some movement in order to reduce these number of audits and actually to make sure that, for example, government requirements take into account the costs and the efforts that are made, particularly by industry, in developing some standards, like, for example, standards based on the Global Food Safety Initiative, type standards. This is an industry-driven initiative at the global level, and essentially built these requirements of preventive control based on what industry has developed by defining the outcomes. And essentially, the government would, the regulators would essentially benchmark what is required, but leave essentially the leeway to industry to have the right audits. Now, shifting to food fraud, I would say again, in this particular case, if I take your example, Sophie, about the horse meat incident, again, the detection was, the identification of the incident was, in fact, thanks to measurement. It was thanks to, the identification of a fingerprint of horse meat in where it wasn't supposed to happen, that, the incident was clearly discovered and then further investigated. Now, going in the same vein of prevention and actually moving upward, not essentially waiting for an incident to happen and then essentially using measurements in order to identify it and manage it. Again here, measurements could be absolutely critical in even trying to foresee what the potential fraud committer could be interested in doing in the future. And right now, in fact, I would say the area of food fraud is becoming a different food safety discipline, because generally a food fraud incident is not meant to be a food safety incident, because a good food fraud incident should not cause a health outcome, because you don't want to be discovered, right? So you want to keep it under wrap, right? Yeah. Absolutely. Yeah. And actually, it's only a bad food fraud incident that goes awry generally, like the melamine incident and
we'll talk
so
about
on.
Melamine,
Exactly. Yeah. So this discipline has become as almost a type of a sort of thriller, investigation or espionage, detective, type, investigation. Is trying to foresee, for example, changes at the economic level of the indexes of commodities, and which commodity may have gone up and have gone down, and therefore could be constituting a potential benefit for a fraud committer to essentially change that particular ingredient. And then essentially here where measurement could intervene is that you therefore identify a potential of a fraud situation there, and come up with the tools that would allow you to get ahead of that, and essentially to be in a preventive mode for quality control, testing to be set, supporting again industry in the way they control the sourcing of their ingredients.
And would that be by monitoring the costs of ingredients, seeing what's going up, and what that would be then what you'd look at and go, this is what they're likely to look at replacing. Definitely. And be one step ahead.
Definitely.
So think like a food fraudster.
Exactly. I mean, I'm going to use an anecdotal incident again, using part of my experience as a regulator, and I believe it was in the 2007 or 2008. So this was actually after the melamine incident. There was an incident coming, in fact, from our part of the world. So again, the Asia Pacific area, where we've identified the addition of phthalates. So these are chemicals that were added to food instead of emulsifiers. And when you think of that, why that happened, well, you actually identify that phthalates have become a cheaper commodity because of a number of environmental laws and regulations that ban their use in other purposes. So they become awfully abundant, therefore at a low price. And somebody actually identified the potential use of that without thinking, of course, of the health repercussions in another type of industry, in an unlawful way and in a harmful way in this particular case. And that pinpoints the way we should be going at sort of trying to forecast these potential incidents by not only monitoring the ingredients, but also monitoring other things, like these substances that may become awfully abundant, and therefore a target for those who might be interested. We
might just talk about the melamine incident, because that was obviously in the news, and everyone heard about that, and it was a huge story. What role did measurement play in identifying melamine as being an issue? How crucial was it to identifying that as a problem?
Interestingly enough, in the melamine incident, it was in fact measurement that practically drove the idea of using melamine as a potential adulterant. And actually, this probably goes back to your first question about the importance of accurate and precise measurements. I mean, we all know that for the most part, protein testing really relies on nitrogen-based methodology. So I'm going a little bit into the science here. So it's in a very basic way. So essentially, these are methods that are not specific to proteins, but they are nitrogen reading methods. At some point, when we know that protein can be an expensive type of ingredient to have, and somebody identified that, well, if we could try to, excuse the expression, fool the analytical system by making sure that the reading reads a protein read, so a higher nitrogen element, without having the protein, we could make money.
It was artificially boosting the protein content.
Boosting. And melamine is in fact a high nitrogen containing chemical. Yeah. And it's actually produced abundantly as a chemical used in a number of plastics industry and so on. And somebody identified that, of course, not thinking of the repercussions, and particularly when you add this particular substance at a high level. I mean, in particular, what was tragic in the melamine incident, and it was in fact a bad food fraud incident from a planning perspective because it got discovered quickly enough, and fortunately in a tragic way, is in this particular case, the addition happened to a food commodity that is infant formula, that is clearly based out of protein, and where not only the levels of addition were high, but also the target population, which is infants, is one of the most sensitive, populations.
So it was a perfect storm,
it was a perfect
really,
storm, again. But in this particular case, we see that it was the measurements that was practically the driver of the idea. And one could argue that by developing more accurate and precise, quality control analytical methods that are targeting now protein, you could help mitigate some of these incidents.
So we might just move on now to the issue of food allergies, because that's a huge issue, not only in Australia, but around the world. And I might ask you, Peter, what role do you think that accurate measurements play when it comes to measuring allergens in food? And do we need to become better at measuring just exactly what's in the food from an allergy perspective?
Yeah.
It's a big topic.
Yeah, it is.
But it affects so many people. It really affects so many people.
It does, but allergens are generally protein based, and we have, excuse me, we have, I think it's 14 declared allergens in Australia, but there are many more allergens out there than are declared. And I mean, I work in, excuse me.
You're right. I know certainly the number of children being identified and diagnosed with allergies is just going up exponentially. So I feel this will be an area that there'll be even more focus on in the future.
And it's an area that will explode, because as we're starting to experiment with all sorts of new items into the diet, like I work in, have been working with lupins as an ingredient for food. And there's been one case of a cross-reactivity between peanut allergens and lupins, and it didn't cause an anaphylactic reaction, but it did cause a severe breathing difficulty. Now, as a marketer of lupins, what do you do? So I go to the government and say, look, we've got this one case of a cross-reactivity. There are some other incidents of skin rashes, people working in a lupin mill. Could you put this as the 15th? And they say, well, not interested. I mean, it's just not significant. But we're chia and all these other things that are coming into the diet, and we're constantly looking around at new opportunities. I mean, to me, we've got to be very vigilant, because on the FIAL website, we now actually host the Allergen Bureau website, which is now used globally, actually, where food companies can go in and look at this website and calculate their allergenicity risk. And it's a really important thing, because if you look on that site and you look at photos of children with swollen lips and eyes closed, and they're not the anaphylactic reactions. And my daughter works in school, and they have EpiPens there with some of the kids, and they ban peanuts. I mean, it's a horrible thing to see it. And I mean, kids die as well, so it's pretty serious. So measurement is critical, but again, there's this balance between what do you measure, what do you control, and what's the freedom for innovation in food, for instance, and there's a balance. So I think we've just got to be vigilant, but I think the measurement is critical to be able to assess danger levels, risk levels, rather than have this blanket regulation that sort of stops innovation. And that's always my balance, is this, I hate regulation, quite frankly, but I also appreciate its absolute need to be there.
Yeah, it's
and
a
there are other
difficult balancing
cases.
act. It's a difficult balancing act.
I mean, melamine, the world is full of, over the last hundreds of years, of cases of contamination that kill people as well as make them very ill. Every single one of them, if you analyse, as you've just pointed out, is commercial. It's how do you make a quick profit out of some situation and hope to get out and not be detected. I think you're dead right to say it's the metrology around it that's important to stop it. And I think we talked as well about a classic where, for food and agribusiness that I look after, that includes beverages, and that includes wine and beer, which is great for us. I appreciate that they are very important food components. But if you look in China, anecdotally, there's more grain sold in China than we actually produce in Australia. So the whole issue of fraud, it's economic. If you're selling at $1,000 a bottle, why wouldn't you try and put, you know, Jacob's Creek in the bottle and sell it under a grains label? So, you know, is there some way we can develop a detection method, a fingerprint, whatever it is? I mean, that's for the future, and that's where I would see we need to take it.
And I might just like get you on, Sam, just back to the allergens. What are the limitations that we have at the moment about detecting allergens in food? How good are we, and what do we need to do to take it to the next level?
Perhaps actually we need to go back probably to the first principles as to why we need to regulate allergens. Because again, as Peter pointed out, practically every food that is protein-based has the potential to be an allergenic ingredient. Our objective, I guess, the collective objective of society is to prevent food allergy incidents from happening. And right now, given that we can't cure allergies, the main thing is really prevention by avoidance. So, and prevention by avoidance happens really by providing information to consumers. Now, for that, the label plays a key role. That's, in fact, the label is the only link between the processed food and the consumer. That's where you get the information. If we go back to the point that, you know, every ingredient has the potential to be allergenic, when do you need to make changes to labeling requirements so that you can enhance the protection of food allergy consumers? Because we already have requirements of declaration of ingredients. We don't need extra regulations. There are already requirements for composition declaration of foods that are processed. And usually that provides the information that may be needed. It's only when you have some situations where some of these requirements can have some exemptions, and for good reasons. I'm going to give you the example of at least one example that we have in Canada, which is spices. Spices can be mixtures of, you know, dozens of ingredients altogether. If you impose the declaration of each sub-ingredient of spices, you would need a meter, or, you know, like you would need a huge food label, and therefore there are legitimate reasons for exemptions from components declarations. For an allergic consumer, that exemption can become deadly if you have an ingredient that has a potential to be allergenic. Yeah. And it's only in those situations where, you know, that enhanced requirements of declaration becomes critical. And I'm going to take the point of, what's the difference between kiwi and milk proteins in terms of being a priority allergens? Kiwi is very highly allergenic. You have people that have anaphylactic shocks as a result of a consumption of kiwi. What is the potential of kiwi being in a processed food without it being declared? It's going to be quite limited, in fact, because it's not a major ingredient that is used in processed food. Milk proteins, on the other hand, wheat-based proteins, egg-based proteins are actually very common food ingredients. That people are
more likely to be allergic to as well.
Exactly. And particularly now, if I take the case of spices, mustard could be used in a mixture of spices. Mustard is known to be allergenic. Wheat can be used in a mixture of spices, and wheat is known to be allergenic. So it is in those situations where that enhanced declaration becomes extremely, you know, pertinent. And that's, I guess, how most of the regulations operate, you know, internationally. Now, when you make a regulatory requirement, and I'm pretty much sure it's the same in Australia as it is in a number of countries that are using what we call the risk analysis, you know, paradigm and the international guidance, mostly from the Codex Alimentarius Commission, a regulator cannot impose a regulatory requirement without it being able to enforce it. And to be able to enforce an instance of an undeclared allergen being present there and it being not declared, well, you need to have a methodology that allows you to detect that. And that's where detection becomes critical in that particular context. In fact, I would say, and using, again, the Canadian experience here, it wasn't until we had methods for allergen detection that we were able in Canada to move forward with an allergen labeling requirement. Because industry, and rightfully so, challenged the regulator for saying, well, how do you want me, first of all, to be able to comply with the rule if I don't have control methodologies? And in the same way, in the same vein, a regulator, you know, not being able really to to enforce its own requirement without those tools. Now, I believe that the scientific community, when I say we, it's the scientific community, has moved considerably in terms of progress achieved in the way allergen detection and allergen analysis is made. We don't need necessarily to identify a specific protein. We need a marker of the particular allergen. In fact, I know through the collaborations that I've had the privilege to have with colleagues and scientists from the National Measurement Institute here in Port Melbourne, that a number of methodologies have been developed in order to help detect allergens in food. The challenge generally is not coming from, I would say, methodologies to detect the allergen at a pure form, because being able to detect a pure form is much easier. It's when you have that allergen present in a very complex environment, such as food. Trying sometimes to extract a peanut protein, a peanut that is at a very minute level from a chocolate matrix. Yeah. That is one of the most complex, chemical composition environments. So good. Can be quite challenging. And that's essentially where, the development of analytical methods and having progress in food analysis is actually needs to go. There's also the other element is that we haven't, unfortunately, developed enough knowledge about the level of sensitivity of consumers vis-a-vis allergy. You can find very sensitive consumers, and you have consumers that tolerate a high level. So when you are at that situation of uncertainty, you are driven by having the lowest detection possible because you're trying to protect the greatest number of people. And this actually is still a challenge in the context of, allergen detection. I mean, I could speak for hours about this.
I could speak for all morning about allergies. I certainly
so
could.
That I'd better stop in this area.
And it's time to open it up for questions to the audience. So we've got two roving microphones.
Thank you. It's Lee Kennedy from DTS Food Laboratories. Often in export requirements and also in the Food Standards Code, you'll get situations where things are requested to be not detected. You mentioned it briefly there with allergens, but we'll get it, say, with heavy metals, where if it's not in the list of itemised foods, then it shouldn't be found. From the metrology point of view, how are we supposed to deal with not detected, where the client requests a not detected result?
Yeah, not detected by what methodology?
Yeah.
I mean, I've had incidents like this with pesticides and herbicides in wheat or in flour going to Asia, and with modern ability to detect, I mean, more sophisticated machinery that's now detecting things in parts per billion and parts per trillion rather than parts per million, which is our paradigm. I've had a shipload of flour on the way to Japan, had the result, and we've had to turn the ship around almost. I mean, in other words, we dump it when it gets there. So I think there's a balance between exactly what you're saying. This is where I say metrology sometimes gets mad as well in allowing us to detect things at a level. I mean, we did a calculation on this particular herbicide, and it was less than 1 drop in an Olympic pool full of water. And, that was enough to turn a ship around just purely on advances in measurement capability. And again, this is where I say there's got to be this balance between regulation, testing, because it can just get out of control.
Do we have a question up the front? Just if you wait for the microphone, thank you.
Good day, everyone. It's Manny Singh from Nestle. I'm going to use a figure of speech. Measurement is a mother, and she has several children called methods. And what is your opinion when you have several methods targeting an analyte or a problem? What are your views from a manufacturer's perspective and from a regulator's perspective?
Sam or Peter?
Yeah. In fact, actually, this is where metrology is interesting, because you need to make sense of the results. And in order to make sense of the results, and in order for the result to be useful, you need to have requirements for methodology performance. And you need also to have the right standardization, so that a result generated by laboratory A using method A and a result generated by laboratory B using method C could be meaningful and could be subject to interpretation. I mean, the simple answer for your question is, as long as you have methods requirements that are met, as long as also, like from the use of the result itself, as well, as long as the laboratories comply with a number of requirements in terms of their proficiency testing, their quality accreditation, and so on, then you can make sense of the results that are obtained. And I would say in chemistry in particular, the trend has moved from warranting a specific method to requiring performance criteria for methodologies, given the level of progress that has been achieved in terms of instrumentation, in terms of also methodologies of extraction. As long as the requirements are met, then the methodology should be valid.
Did you have a quick comment, Peter, or we've got another question here?
Well, I do. But as science advances and methods of measurement advance as well, I think regulators and customers as well with quality systems are years behind in catching up. A classic is near-infrared. So we use near-infrared in flour milling to do rheological properties. We could do 34 tests that were done that would take up to 6 days, including ash content, the whole lot, that were required by customers. We could do it in 45 seconds with more accuracy than the old methods, but no one would accept it because they did, and I can't explain it either. Why does it work? But it is more accurate, more consistent, more reliable than the methods that everyone accepts. So there's a role here for advances in science being brought into,
as a
catch-up.
Yeah, that happens a lot in medicine too. Yes.
Hi, David Lee, Food Matters Consulting. I just wanted to go back briefly to Peter was talking earlier about the predictive nature of testing rather than testing the end product. And just as a highlight, I guess, my background was in the dairy industry, and I remember visiting a cheese factory in Western Australia. We were exporting overseas and sending it all around the country. And I walked into the supervisor's desk, and he had the QC sheet for the day filled out at the start of the shift. And I questioned him about that.
That's a
He said,
novel
well,
approach.
that was the way that I was taught by the previous supervisor, because the results are always the same. And it saves me having to do all the measurements during the day. And I guess I just wanted to share that, because to me, it's the human element. We can have all the best tests in the world and the greatest QA systems and designed
That's a
QC
good
sheets and everything can be there, and you can come in and audit those sheets. But what goes onto those sheets is really a matter of how well committed and trained and aware are the people who are actually there. And the human error is just something that I think we need to put in the whole measurement discussion. So, yeah. It's an ongoing, I mean, it's the human element, isn't it? I mean, in terms of NIR, what we were doing was to try and do inline NIR as processes were occurring and get measurements to alleviate that problem, but it's a constant problem.
So we have one question next to this gentleman and then up the back.
Good morning, my name's Andrew Hine from Agilent. We've heard about infrared just then, we heard about the Barry Inglis metal, which is an infrared-based technique. I know a bit about it, it's portable, it's handheld. And my question is, from a manufacturer's, a regulator's perspective, do you see a future where a consumer, enabled by technology and empowered by the regulators, can play a part in the measurement and regulation process with respect to contamination and fraud?
Who'd like to jump in?
Well, I would see that if the consumer has, and the consumer should have a role in it, but if it gets to the stage where a consumer goes to a supermarket and detects it's too late, there should be processes in place that are detecting it before. Sorry?
Yeah.
It's not too late if it stops them eating something.
No, but what I'm saying is if the processes are in place, and I'm going against some of the earlier things that I say about where does regulation start and finish, if the processes are not manipulated artificially in a factory and they're robust and they're reliable, that should never happen. But you should never remove that ability for sure. I mean, and that's going to happen.
The trend has already started, in fact. I mean, in the sense that there are some consumers already. In fact, there are some kits that are, like, for example, in gluten detection, there are some kits that are targeted to consumers' use. In fact, this particular area of rapid methods is probably the area that would warrant a little bit more attention, both from a standardization perspective and validation, but also all the caution around the way they should be used. And I guess actually some work is required there, not only on the part of regulators, but also on the part of those method developers and the way the validation approach is to be pursued.
So we have a question up the back.
Yeah, thanks. David Halliwell from Deakin University. I'm just wondering if you think that our measurement techniques have fast overtaken our ability to actually interpret what those results mean, particularly for low level and chronic levels of contaminants, and whether we should be putting more effort there. Thanks.
Yeah.
Go on.
Yeah, I cannot agree more, in fact, with that statement. I think we have a number of situations where that statement has been clearly confirmed. I think Peter mentioned we have an ability right now to detect parts per trillion of a number of chemical substances in food. We have identified also, thanks to, in fact, low-level detection, some substances that we did not even suspect their presence in food are being found, and our ability to understand the potential health impacts of these substances and their presence is actually lagging behind in comparison to our ability to detect. But that being said, it doesn't mean that actually progress should be stopped in that particular area, because clearly when you have an early identification of an issue, you drive progress in the other side.
Yes, gentleman at the back.
Thanks. It's Mustafa Kansas here from Agilent Technologies. Throughout this morning, I haven't heard much discussion on packaging, and packaging is an important part of food. It gets shipped with it, though we may not eat it, not usually. It forms an integral part of its integrity, preventing things getting in, things getting out, preventing spoilage, biotic, abiotic spoilage. What are your thoughts on the measurement of packaging within the context of food safety?
The measurement of packaging? Well, if you've been to other venues where I've talked, packaging to me is one of the most neglected areas of research regarding food that I can think of, and it is the future. So all sorts of active packaging, gas permeable barriers, selective, osmotic, barriers, all those sorts of things. I mean, I've thrown challenges out to the Packaging Institute as to, detection, colour indicators, whatever, on shelf life, on flavour, volatiles. I think this is an area that we really need a lot more research in. And if we're going to, which is what happens when globalisation occurs, we extend our supply chains, we extend our need to have extended shelf life. This whole issue of food safety becomes more and more essential to have a handle of it, and I think packaging will and must play an absolutely critical role in it. So I just do not think we do enough in research around packaging.
And Sam?
Yes, and actually I concur, in fact, in the sense that innovation in packaging is one of the most evolutionary area in food production. I mean, foods change a lot in the way they are presented to consumers, the way they are aimed at lasting longer, changes in all sorts of things, and packaging play a key role. From an international regulatory perspective, it is in fact the area where there is the least guidance in terms of the way packaging are managed. There are some leading jurisdictions, mostly OECD countries, that are, having a robust regulatory framework in that context. But knowing that, globalization of the food supply and the fact that we rely heavily on imports, it is an area that could be contributing the most in terms of chemical food safety hazards in the future. And I totally concur with the idea to have more emphasis right now in investigating the issue. Like, for example, new formulation of packaging material, identification of techniques to look at migration options into the food, but also looking at innovative regulatory systems that rely more heavily on collaboration, because frankly, you cannot have every food safety regulatory jurisdiction in the world developing its own regulatory framework for packaging. It's one of the most onerous regulatory systems that could be.
Thank you.
So we've got a few minutes left, so we've probably got time for one more question if we have any more questions. Otherwise I've got plenty. So I guess my question that I would like to just put to both of you, and you've alluded to this, Peter, already, that if Australia wants to be known as the innovation nation, which we do, how crucial is it that we really act on some of the issues that we've discussed today, that measurement and the food industry and work together so we can develop innovative new ways for this changing industry?
Well, I guess in one of the discussions that we had earlier, the area that I really feel we need to get the ability to measure is around sensory, aromas, this whole new developing area of tribology, which is all around, structure, function of food, detection. And I mentioned in an earlier discussion about an earlier experience in Taiwan selling noodle flour into the market, and they were talking about the Q factor in the noodle. I had no idea what they were doing. You can't measure it. It's mouthfeel. Even when explained, I couldn't even understand it. Some of the umami concept of flavour and things that in a Western diet we have no knowledge of, no experience of.
But if we want to sell to Asia,
for the future, where Asia is supposedly the future for Australian food production, we need to understand it, and we need to be able to measure it. Not just understand it, but measure it and build it then into what we do in Australia, because there's no good just sending a bucket of wheat or a loaf of bread or a glass of wine into Asia when the palate is completely different. We think of China as China, and you think of all of the different regions and the different flavour profiles that are in there. We've got to understand that. We've got to be able to measure it. We've got to be able to quantify it and build that into our innovation process.
Samuel?
I guess I'm going to look at this from, again, my experience as a former regulator. I guess I've always looked at Australia as as a leading jurisdiction in the way it managed food safety, and I think it's mostly in the way partners and stakeholders operated. Again, you are probably one of the countries that modernized these food standard systems amongst the first in the world. You rely heavily, this is again the view of somebody from outside, heavily on collaboration between government organizations, regulators, and industry. And just using the example of the Allergen Bureau and the work that was conducted in developing risk management approaches developed by industry itself to meet consumers' concerns in a manner that actually achieves most of what a regulator wants to achieve in this area, is probably an innovative way of doing business to manage an emerging risk like, for example, food allergy incidents. And I think you have an approach that could be built upon to position the country quite well in meeting the innovation challenges of the future.
That sounds like a great place to end our discussion. We could talk all morning, I certainly could, but please thank our guests, everybody. Peter Schutz, Sam Godfrey. Thank you so much for what's been a really fascinating and engaging discussion, and really, really welcome you both here, and thank you very much for your participation.